Hello. This is going to be a quick demo of the 6502 processor emulator that I wrote in Rust. And a little bit of background on this. I began this in C++, um, inspired by One Lone Coder on YouTube, and uh, I was experimenting with vibe coding, and I built a RAG agent with an Olama uh, model. I believe it was Phi, the Microsoft open source model, and I gave it all the documentation. I had a lengthy prompt. It was probably a couple of pages long, describing that I wanted a psycho-accurate processor, describing what the outputs should be, like providing it tests what the input should be and the output should be. It was extensive, and I'm not a great prompter. That's something I'm still trying to learn. But that first iteration, that C++, was a disaster. Like, nothing worked. It was because my thought was it would at least give me something to work with, and then I could either direct it or code review or fix things myself. But it was just bad. So then I studied all of the documentation, and I did two versions. And because I'm an object-oriented programmer, sort of by nature, I've been doing this professionally for 25 years. It's been mostly object-oriented stuff, going back to C++, even into C Sharp, PHP, Ruby, and Java, obviously. So I built a PHP version, purely object-oriented. It worked great for really simple things, and I was kind of inspired by Ben Eater and his 6502 breadboard computer, and I actually emulated that perfect, at least up to where he did the RS-232, and that got really hard to sort of emulate an emulator. It was tough, but we got it working. And one of the first things I wanted to do using the 6502 was to create a Nintendo emulator, and that was in PHP, and it was awful. It's not powerful enough. It will render, and you will see things, but it renders something to the effect of one frame every 3 seconds. Something to that effect. So it's not powerful enough. Even using the opcache JIT, which helped it a little bit. We got at one point, I think I got 1 frame per second. It was bad. So then I studied a little bit more about functional programming, and although Go is not per se a functional programming language, you can do some functional stuff. And so I wrote the emulator in Go, which was completely different architecture, obviously. And then when that was done and working, I did build a successful Nintendo emulator, which is on my GitHub. But I'm still an OOP guy. So I had a conversation with Perplexity, which is really the only, excuse the phlegm, really the only AI I tend to interact with. And as I was studying Rust and getting some concepts, I figured out that I didn't have to completely give up OOP to do this in Rust. It rebrands some concepts, and you lose the bad parts of OOP, which inheritance, obviously. But even as an OOP programmer, I tend to lean towards composition over inheritance anyway. So it's a different sort of polymorphism because everything is static and runs right then. But the architecture itself from the PHP version came over to Rust sort of one to one. Again, excuse me. So that was pretty cool. So I'm not going to go through the technical stuff or the code, but what I want to show you is this here. This website is where you can get CC65 it's a 6502 compiler. It takes assembly and turns it into machine code. And so one thing I do want to show in the code, the bus is where you bring all your own stuff in, your memory, your IO, and all that stuff. And what happens with the 6502 is it has a 7-cycle startup, and then it immediately looks for something at 8,000. And 8,000 is external to 6502, so you have to bring in your own memory. So what I did was for testing the CPU itself before I have any system to connect it to, is that I provided what I call a simple bus, and it's just all it does is initializes 64K of memory so that we can test it. So in here I have let me learn how to spell. I created this assembly program, and literally all it does is increments the accumulator A register from 1 to 10, and once it hits the break, which once it hits the break here, where it's out of the loop because it has hit 10, and then it'll stop. Okay. So to show, and then using the here the assembler and linker, you can assemble that into bytecode, which looks a little bit like this. So there's the bytecode. So we can run and watch this work. We can use a delay as one of the. You can also set a max, which is it'll stop after a certain number of instructions, just in case your program runs wild. But the delay it basically sets the clock speed. So at 1,000, we're at 1 hertz. We're moving 1 cycle per second. So, and here's the output, and we can watch what happens. So these are the instructions. This is the next instruction. We have a update of the status flags, and then this is what's happening, what's actually in the accumulator each time. Incrementing the accumulator is 2 cycles, so you'll notice it's going. Starting it up was the first 7 cycles. That's why it's behind this so much, or behind this so much. So then we can watch it, and here it clears and then adds and then goes until break, and then once it hit break, which is at 009, so it was literally only 9, like we saw. Oh hell. So there's basically 9 instructions here, and that's what happened here. We started at 8,000, went to 8,009, and so that's the processor working. And so you can take this, import it into a system you want to emulate, and my idea next is to emulate the Commodore PET, because I do have copies of the ROMs, the character ROM, the kernel ROM, basic, and one other. I don't remember what it was, but I already have those. Those are available, and so I can basically plug those into the processor and have a Commodore PET, and I think it will be the one of the one of the more recent models. But we'll see what we have available. But that was a demo of the 6502. I know this is a terrible video, my first video, but maybe we'll get better. But thank you if you made it this far, and we'll talk again soon.